Sir Isaac Newton's laws of gravity are considered one of the most significant scientific discoveries in history. Newton derived his laws through a combination of mathematical reasoning, experimentation, and observation. Sir Isaac Newton was born in Manor House in Woolsthorpe near Grantham in 1642. The same year Galileo died. His father, also called Isaac Newton, had died 3 months before his birth, and his mother, Hannah, married the minister of the nearby church when Isaac was 2 years old. Isaac was left in care of his grandmother and effectively treated as an orphan. He attended the free grammar school in Grantham, but showed a little promise in academic work, and his school reports described him as idle and inattentive. His mother later took Isaac away from school to manage her property and land. Soon he showed that he had a very little talent or no interest in managing an estate. An uncle pursued his mother that Isaac should prepare for entering university, and so in 1660 he was allowed to return to the free grammar school in Grantham to complete his school education. He lodged with the school's headmaster, who gave him private tuition, and he was able to enter Trinity College in Cambridge in 1661 as a somewhat more mature student than most of the contemporaries. He received his bachelor's degree in April 1665, but then he had to return home when university was closed as a result of plague. It was there in a period of 2 years, whilst he was still under 25, that his genius became apparent. At that time, the dominant view of the universe was based on the work of Greek philosopher Aristotle, who believed that the natural state of objects was at rest and the motion required a constant force to maintain it. Newton, however, challenged this idea, and believing that motion was an inherent property of matter. In the years followed, Newton constructed a series of experiments to test his ideas about motion. He studied the way the objects moved under different conditions, observing that the same force is required to accelerate an object with a given mass, regardless of its initial velocity. Newton then turned his attention to the force of gravity, which he believed was responsible for the motion of planets and other celestial bodies. He observed that the planets moved in elliptical orbits around Sun and realized that this could be explained by a force that decreases with distance. The legend is that Newton discovered gravity when he saw a falling apple while thinking about the forces of nature. Whatever really happened, Newton realized that some force must be acting on a falling objects like apples, because otherwise it would never start moving from rest. Newton also realized that moon would fly off away from Earth in a straight line tangent to its orbit if some force was not causing it to fall towards the Earth. The moon is only a projectile circling around Earth under attraction of gravity. He was aware of Galileo's work relating to the trajectories of projectiles, and in his great work Principia, published in 1686, he considered what would have happened if one fired a cannonball horizontally to the top of a high mountain where air resistance could be ignored. The cannonball would follow a parabolic path to the ground. As the cannonball was fired with a greater and greater velocity, it would land farther and farther away from the mountain. As the landing point becomes farther away, the curvature of Earth must be considered. In a more popular work published in 1680s called A Tractarian System of the World, he included this figure. The mountain is impossibly high in order for it to reach above Earth's atmosphere. However, this is a thought experiment and not a real one. One can see that the velocity gradually increased. As the velocity gradually increased, there would come a point when the cannonball would never land and would be in an orbit around Earth. This led Newton to his famous inverse square law. The force of gravitational attraction between two bodies decreases with increasing distance between them as the inverse of the square of their distance. However, Newton also had a problem. He felt that he could not publish his law until he proved that the gravitational pull exerted by a spherical body was precisely same as all its mass were concentrated at its center. This can only be proved by calculus, and it took Newton a while to develop the ideas of calculus, which he called fluorinons. It was only then that he felt confident enough to present his theory to the world. The proof is not difficult but rather long. As a sphere can be regarded as a set of nested cells, the required proof is to show that the gravitational attraction of this thin cell is as if all the masses were concentrated at the geometric center, that there is no requirement that the body is uniformly dense, but it does require the density at a given distance from the center is constant. The body must have a spherical symmetric mass distribution. Newton realized that the force of gravity must also be directly proportional to the object's mass. Also, based on his third law of motion, he knew that if Earth exerts its gravitational force to an object such as Moon, then that object must exert an equal and opposite force on the Earth. He thus reasoned that due to this symmetry, the magnitude of the force of gravity must be proportional to both the masses. Newton's laws of gravity not only explained the motion of the planets but also provided a framework for understanding the motion of objects on Earth. Sir Isaac Newton's laws of gravity were remarkable achievements which revolutionized our understanding of the universe. Newton's insight into the nature of motion and gravity were based on careful observation, experimentation, and mathematical reasoning. His laws of gravity remain the center stone of modern physics, providing the foundation for our understanding of motion of objects in space and on Earth. So thank you for watching this video. We hope that you found this information informative and helpful. If you have any questions or comments, please feel free to leave them down below. Don't forget to like and subscribe to our channel for more videos like this, and also don't hesitate to share this video with your friends and family who might find it interesting. Thanks for tuning in, and we'll see you in the next video.